So this week in med school, we're talking about fluid depletion and dehydration. And so I was trying to figure out how this all relates to like giving fluids and how just trying to think of an intuitive way to think about sodium in the extracellular space and how fluid distributes between intracellular and extracellular fluid. So I came up with this graph, and I think it summarizes it really nicely. So I hope it'll be helpful for you too. Okay, so in this graph, we're plotting the volume change of the extracellular fluid against the sodium concentration of the fluid that's being added or lost. So let's say that the sodium concentration is isotonic. So let's say you're adding isotonic saline. You're going to get all of that fluid going into the ECF, right? Because there's no driving force, there's no osmotic change that's going to pull or push fluid in or out of the ICF. So isotonic saline all goes in the ECF. You can actually just plot the intracellular fluid volume change on the same graph. So in the case of isotonic saline, you would just get zero change in ICF. Let's say you gave pure water, like somebody just drank pure water, you would get about 0.4 V going into the ECF and 0.6 going into the ICF, even more going into the ICF. If you gave 2 times hypertonic saline, you'd be giving so much salt that you'd actually be pulling fluid out of the ICF, and you'd therefore be putting like extra fluid into the ECF. So your cells would shrink. And that's why you can't drink seawater. So you can just draw a line through these, and it's an actual continuum. So depending on the salt concentration of the fluid you give, that determines what proportion goes into the ECF versus the ICF. So you probably already knew that, but the realization I had is that we're talking about volume depletion and dehydration. Those are just the reverse processes. You can refer those same processes to this exact same graph. So case 1 is V equals 1 liter, let's say. So that's what we were talking about, is giving fluids, giving isotonic fluids, giving pure water. But if you consider case 2, which is loss of fluid, for example, V equals -1 liter, now losing 1 liter of isotonic saline is the same thing as volume depletion. That would be like a 1 liter hemorrhage. So you're losing water and sodium proportionally out of the extracellular space. And so you would lose 1 liter of extracellular volume and lose nothing from ICF. In other words, volume depletion and giving normal saline are just the reverse of one another. All you need to do is reverse the sign of the volume that's changing. The same is true of dehydration and drinking pure water. So if you were to dehydrate, that is, you're losing water but not sodium, then proportionally like 0.6 liters of that is going to come out of the intracellular fluid, and 0.4 would come out of the extracellular fluid. So that's just the realization I had, is that you can plot those taking fluid and losing fluid on the same graph, and you just flip the sign of the volume that's coming in or going out. All right, that's it. I hope that's helpful.